Here we want to use superposition to find the potential V out across this 5 kilo ohm resistance. So we don't need to use superposition, but if we wanted to, we would need to remove each of these independent sources individually and then calculate the value of V out and then use the algebraic sum, i.e. add those potentials together. Now we don't remove the dependent source, we only remove the independent sources. So we remove them one by one. We remove this. That means for a current source, you would replace it with an open circuit. You would break the circuit. And then we remove the second current source. So let's redraw the circuit after removing each of these. So I'm going to remove this, replace it with an open circuit, and then replace that with an open circuit. So in each case, we only have one independent source. So if we look at this circuit here, we're trying to find this potential. And this potential in the end is just this current multiplied by the value of the resistance. So V out is simply the current, which is twice I1. So this is I1. This is the current 2 times I1, and that's what passes through our resistance. So this is what we're trying to find. So in this circuit, once we find I1, we then know what twice I1 is, and we can find V out. Now it looks like we have 2 amps going up in this branch. This is an open circuit here, so nothing goes this way. So we have 2 amps going here, and then it's split between this branch and this branch. So we can use the current divider to find how much is going down this branch. So it's 2 milliamps multiplied by 2.5 divided by the sum of the 2 resistances. So that gives you 0.4 amps going down here. That means we would have twice that going up there, 0.8. And if you multiply that by 5, that gives us 4 volts. So that's the potential V out without this independent source. And we can do exactly the same after replacing this and removing this source. And it just happens to be the same numbers. So you have 2 amps going in this direction. Nothing's going here because it's an open circuit. So we can use a current divider to calculate the current I1 in our second scenario. And that will also give us 0.4 amps. And then you multiply twice that times 5, that gives us 4 volts. So we now know that it's 4 volts in both cases. Using the superposition principle, we can simply add these 2 values of potential. So 4 plus 4, that gives us 8 volts. So 8 is our final answer. That's the value of the potential V out using superposition.